All right, so we're going to start with number 7, where we have object 1 starts at 25 meters and moves with the velocity of this. Object 2 starts at 13 meters and moves directly towards object 1. The two objects collide after 0.67 seconds after starting. They want to know the velocity of object 2 and the position of the objects when they collide. So in the Y for this one, I'd start off probably with a fact that may seem too simple, but it's one of those ones that trips people up. What two things must be identical for the objects to collide? Place and time. They have to be at the same place at the same time. And I would start by showing that I understand that. So at same place at same time. Doesn't matter how they're moving, what color they are, anything else. Just same place, same time. And I might say things like they are moving towards each other. So their velocities have opposite signs. And that's probably enough. Oh, I didn't open up my equation sheet. I knew I forgot something. All right. I'm going to do a diagram just to help organize myself. Now, you could do this diagram as part of your how or part of your why. Because on my format up here, I have a nice little box to draw the diagram in. That's what I'm going to do. These are the sheets, by the way, that you'll get when you work on tests. I'll post a PDF of this. This is the format for tests, so you can have that format. Let's see. My object starts at 25, moves negative 13, moves direct. Okay, so I'm going to say here's object 1, and it's at 25 meters. Is it okay with everyone that I say to the right is positive? Is that okay with everybody? Okay. Oh, my object 1 looks kind of creepy. My object 2 is here at 13 meters, which means over here someplace is 0 meters, right? And object 1 is moving that way with velocity 1. Object 2 is moving that way, velocity 2. And they tell me that they meet somewhere in the middle here at time, delta time equals 0.67 seconds. Good? Okay. So I know a lot about where they start off, how one of them is moving, and the amount of time. This is where I run over to my equation sheet and say, oh, look, I've got an equation that's where I end up. The position I end up at, D, is where I started. That's what the naught means at the beginning. initial. And my velocity multiplied by my change in time. How did I know that that v was velocity? It's got the little vector symbol, right? That's how, so these positions, so everything in there, the sign matters. So I'm going to use that equation back here. So I'll start off, it's a good idea to write your equation. Now remember, on the example problems, you guys remember there was a rubric for all of this, right? So I'm going to try to follow that rubric just out of memory because, you know, I want you to see what it looks like for when you do it. So for object 1, let's make object 1 blue and make object 2 green. How about that? So for object 1, it's going to end up at D, where they both end up. It's starting at 25 meters. It's moving at negative V1. And it's doing it for delta T. Well, yeah, I do know those values. Why don't I fill them in? So my V1 is negative 5.5. And my delta T is 0.67 seconds. For object 2, it's also going to end up at D. It's starting at 13 meters. I don't know how it's moving, but I know it's going for 0.67 seconds also. Right? So now I can set those two equal to each other and have 13 meters plus V2 times 0.67 seconds equals 25 meters plus negative 5.5 meters per second, 0.67 seconds. And I do some math, right? Which is the non-exciting part. And I get an answer of 12.4 meters per second. Notice I automatically recorded in 3 sig figs. I remember to add units. Let's see if I'm right. I like when I'm right. Yay! That green correct bar makes me very happy. So now part B, what is position of objects when they collide? Oh, that's solving either of these for D, right? Because D is our position where they both ended up. Yes? No? Right? So I'm going to solve the blue one for where they end up. So 25 meters plus negative. And I get 21.3 meters. Well, that makes sense because that's between 25 and 13, right? So logically, at least it's between where the two start. Let's see if it's right then. at this gram bullet with this speed, what is the kinetic energy of the bullet? So your Y would show that you understand what kinetic energy is. I mean, this is a very straightforward problem, right? So it would be, kinetic energy is influenced, I spelled that wrong, something, by inertia and speed. And you could expound upon that, what happens if the inertia goes up? What happens to kinetic energy? It goes up also, yep. And if the speed goes up, it goes up much. So you might say speed has a larger influence because the speed is squared, right? Do you have all these done? Cool. But you got all that out. Excellent. Good work. So feel free to help other people if they need it. Nice work. Most of you got them all done, right? You got them all done? That's okay. Good job, guys. Just what you did last night. Oops. I don't want that. I want this. So, my kinetic energy, I described my equation here, right? So, KE is 1/2 inertia speed squared. The kind of nasty thing they do to me here is grams our base unit for inertia? No, we need kilograms. So we've got to convert the mass here to kilograms to be in proper units for inertia. What about our speed? We need meters per second. So they threw weird units at me to see if to have me do it. And then look what the units they want my answer in. Kilojoules. So they're messing with my units life. So let's see. So I should do those conversions. 9.50 grams equals 9.50 times 10 to the minus third kilograms. And 1.5, oops, 1.50 kilometers per second equals 1.50 times 10 to the third meters per second. Good. And now it's plugging in and hope my calculator works. Equals 1/2 9. Sorry, I ran out of room there. Where? I get, yep. I got 1067.5 joules, but they want the answer in kilojoules. That'd be 10.7 kilojoules. Yeah. Let's see if I got it right. Now, the kind of neat thing is if you didn't want to use kilojoules and you wanted to use joules, you could just change your unit to joules in there. Get rid of the little K, and it will mark it correct. Okay? The units that are put in there are, hey, this is the units we think you should use. If you want to change them to something else, as long as your answer is consistent with them, it'll still work. All right, number 4. The roller coaster moves a certain section with track with average speed of 13 meters per second. How much distance does it cover in 5.4 seconds? So, I would start off showing I understand speed. Speed is the rate distance changes. Right? And that might be all I need, because it's really just about speed. I'm going to go to my equation sheet again. I'm going to grab my definition of speed here. Now, notice that says velocity equals just change in displacement or displacement over change in time. Just for space, I didn't put the speed one up there because they're so similar. You have speed equals distance over time. So it's the same rate equation, right? And I know that mine moves at 13 meters per second. I don't know what distance it covers, but I know it travels for 5.4 seconds. And then just solve for distance. Yeah. And I got 70.2 meters. You got it? Well, let's hope I got it right.